Analog IC Design in the 21st Century. It's subtitled that it's jokingly kind of like the 20th century. Yeah, my name is Pepijn. I have a website and a Twitter and a bunch of other stuff. And this project that I will be talking about is funded by NLNet and my crowdfunding supporters. So to get started, a brief history of like key moments in the development of analog IC design. In 88, Cadence was founded. In 89, SPICE 3 was released, and nothing much happened, and that's how we get to today, basically. Of course, there are a lot of stuff happened, but yeah. So IC design is kind of a very closed and conservative space. And what used to be like this lambda rules and this academic projects, but as the node sizes grow smaller, the cost goes up and the complexity goes up, and foundries move to like their proprietary stuff and add more NDAs, and the tools start to use more proprietary formats. And of course, as the costs increase, so does the risk of getting it wrong. So everyone's also really risk averse and just don't change it, just keep doing what works. And to paraphrase a few quotes, nobody gets fired for buying Cadence. And about startups in this area, either die an innovator or live long enough to become acquired by Cadence. Yeah, that's what happens. Like, oh, this is cool company that make all these fancy new things, and then they get acquired and they become like a button in Cadence software. And this is like, as I see it, like you can be like about open source very naive and but like the real problem, as I see it, is design reuse. And because of these NDAs and the tool licenses, you're just not allowed to share your design files. And this is a real example. When I was studying at the University of Twente, there's this whole array of assignments you could pick from. And one of them was just make us a Certus IP block. And then like, what is the scientific value of novelty about this? And it's nothing. They don't have an IP block. They can't just get it from another university. They have to build it themselves because all these NDAs and licensing. I think in particular in the educational licenses, like you're not allowed to do commercial stuff. And if you design it and publish it open source, anyone can do commercial stuff with it. So you're not allowed to. And then this Sky 130 that came around is super exciting, super cool. But it's only half the thing, because even if you have an open BDK, if your tools don't allow you to publish your designs, you're still nowhere in terms of design reuse. So that's why you need both. You need the PDKs and the open tools. Sort of the old school open source analog tool chain is ngSpice, which is directly descendant from the original Berkeley Spice. And then for schematic entry, there's Xscheme and the Magic layout tool. And here you can see how they look like. I mean, they're powerful projects, but they're, well, I think they're a bit dated. And then there's these newer projects. So SICE is a simulator by Sandia Labs. It's not like in source code derived from Berkeley Spice, but uses modern solvers and techniques. It still supports the same models and sort of the same paradigm, where it's sort of like a tool that takes files and outputs to more files. And KLayout, same story. It's like a more modern KDE-based layout editor. And it's still same thing, drawing rectangles and KDE desktop app, but it's at least a little bit more modern than Magic. And well, that my tool, Mosaic, which aims to be a more modern schematic entry and simulation tool. And worth mentioning, my other job is working on Julia Spice, which is a Spice simulator that I gave a talk for about at JuliaConf a while back. It's a bit different paradigm than just having a simulator as a binary, where it's more like a library that you can integrate in your tool flow and automation. And the other thing, which is also not open source as far as I know, well, Julia Spec might be open source in the future, by the way, but it's just now we're still working on it. Analog Designer Toolbox is a method where you sort of take topologies, existing topologies, and you sort of specify the design space that you want to explore, and by using sort of lookup methods and, well, this whole integrated approach, you can very quickly sort of explore the whole design space rather than wiggling a few parameters and manually trying to analyze what's going on. As I said, it's free for non-commercial use, but not open source, so it's interesting. But if we're talking about open source, well, it's there. So now let's look at analog design. Like, what do actually people want to do? Because that's an important question. What is it for? And as I see it, there's sort of 3 types of analog IC design that sort of have very different users and requirements. From the digital people, they mostly just want, I have this system on a chip or this digital thing, and I want like an I/O block to analog shit, and they don't really care about design or about the requirements. They just want some functionality, basically. And I think this is basically, they just want a ready-made block. Maybe this something like an analog generator can service this crowd. I'm not sure. And then there's like the commercial full custom design, which is not like research, so they largely take proven designs and have a specific set of requirements and then want to explore or design a specific thing. And I think this is sort of the target of Analog Designer Toolbox, where you have this fixed set of topologies that you want to explore. And lastly, there's research, where you just build brand new stuff and state-of-the-art requirements from scratch. And there you can't really deal with like generators or algorithms. You just have to do the state-of-the-art thing at the transistor level and tweak every little parameter. And in terms of what I'm targeting is more the last two. I think definitely research would be an option, but I think with sort of the right guided design simulation techniques, you can do some of what Designer Toolbox does in terms of exploring the design space better than staring at waveforms. So, a bit of context. And of course, like I said a bit critical things in the beginning about the existing space, but also not let's forget that they have been in this space for decades, so they do some good things. And it's always worth preserving the good things. So also, if there's anything that you particularly like about Cadence, please share, because I love to hear it. Some things that I came up with here is one that lets you decouple the components from the implementation. Because what you see in Spice, you just hard code this model and it goes there in a netlist. It's just like a netlisting language, right? Whereas like more like VHDL in that sense, where you sort of have an entity, which is sort of the interface of the thing, and then multiple implementations, which is crucial for larger designs where you want to be able to like sub out a part or like have different test benches or all sorts of things to have sort of a viable design and simulation strategy. And this goes hand in hand with the second point, where you have to have this hierarchy support. Because if you look at like the PCB space, there's like KeyCard these days, and it's pretty good, but it's like very much like flat designs. You just put the components there. You can do boxes if you really want to, but it's not really hierarchy in the sense where you have in chip designs, 50 levels or whatever. So this is important for IC design tool. Another thing that I think is valuable compared to like raw Spice is where people don't want to run a transient simulation. They want to get a result, get a measurement, get a specification. And I feel like Cadence does that more, where you have like the specific measurement for like high IP3 or compression point or whatever. Whereas more sort of the thinner Spice wrappers are like, here, do a transient simulation and here's the data and good luck. And another important thing that I think Cadence does it does is back annotation of results, and it's a couple of steps where you have to go in some menus and click all the things, and so it's not like intuitive or like, but it's there, and it's a good thing where you can sort of see the operating points of your transistors or this kind of stuff. And the last thing on this list is not a complete list, but scripting. And Cadence has this weird scale language, so in that sense, it's not like ideal, but it's still a powerful thing where you can, you want to do a thing and the UI doesn't do it, but you can write a program that automates it. And well, it's nice to have, and I think important. And also I want to look at some other industries because, I mean, it's an IC design tool, but we're not the only industry that uses computers to draw things. So I think it's very valuable to take inspiration of what other people are doing. And well, mostly in the UX UI department, some other industries just have nicer stuff. Like if you look at Figma, it's a very polished tool and it's very smooth and pretty, and similar to other spaces. In particular, I want to look at, I'll discuss a bit the CAD design, like SolidWorks. And one interesting thing they have there is parametric design, where you don't just specify a voltage or a current or like a width or a length. You specify things in relation to another. So like this component is as long as that other component, or it's like parallel to this other component, and everything. Like, it really drives you to define things relative to other things. And the really cool thing about that is that when you change the thing, all the other things change along. So I think if we can take this concept and apply it to chip design, this would be really valuable. It's a bit like tricky how you do this in practice, but it's worth thinking about. Like, you have the threshold voltage and you want this other thing to be biased like 0.2 volt above the threshold voltage or whatever. This kind of stuff you should be able to specify and make it clear in the schematic that that's what's happening. And then it also makes it more easy to change things. And second thing from graphical design, where I'm basically looking at Figma. There's other tools, of course, but really funny. They have this like live collaboration thing, and it's like not done in the IC design space. Like nobody does this. And they also say in their blog, like, yeah, people thought it was like a gimmick and that it was super weird, but it proved super valuable in the end, and now people love it. So this is something where I'm thinking, what if collaborative chip design? Let's just try. Maybe it's a gimmick, maybe it's super valuable. We'll see. And also it's a web-based tool, which is also, I think, really important. And because like I've talked to people and they said like, yeah, for every 10 chip designers, you need like someone who manages the software installation, because what tends to happen, or from, at least from my limited experience, is they have this installation on this server and you go with a remote desktop into it, and yeah, it's a pain to manage and it's very sluggy. If you just have a web-based tool, zero setup, zero lag would be ideal, I think. And finally, from digital design, I want to steal test benches, because I think too much of analog design is like staring at waveforms and like your eyeballs are the test, basically. I think we should have more, tests similar to digital, but it's of course a different thing to do in analog design, but it's still a concept that's worth stealing. So now about like sort of the things that I'm thinking about and what I think, my philosophy basically. The starting point is basically user-focused design. Like I don't just want to build a tool for me. I want to build a tool for IC designers. So, I mean, I have a background in web design, but I took this extra UX course to like get really into how do you approach this. And then they're like, okay, do user research. And I'm like, yeah, okay, NDAs was really difficult. So in the end, I settled for interviewing people. So like I've interviewed like, I don't know, 10 people or something. From like industry, academics, hobbyists, everything. Some of these interviews are on YouTube, somewhere private. And then, yeah, this is like the software mantra, but in this sense, I think it's also important to like build a thing and then get feedback, improve the thing. So if you're interested in this and you want a full schematic entry, definitely play around with it and let me know like what you like, what you don't like. And last thing, with the money from NLNet, I was able to hire a designer to actually make it smooth and pretty beyond what I would be able to do myself. So that's also cool. Yeah, another key idea, short feedback loops. And I stole this idea kind of from these two projects. One is his talk by Brad Victor, which is mostly like it's about inventing on principle, but his principle is like the designer should be able to see what they do, and seeing what you do means instant feedback. So he has this demo where he does that with a small circuit, which is really cute, it's really nice. But I think it doesn't really scale to large simulations, and especially like if you have megahertz range signals in real time, that's not making sense. So like I think it's a nice idea, and I want to steal the good parts of it. But I think for like a professional IC design tool, you need to like skip the gimmicky slow parts and do only the important part, which is like the feedback, if you can. Because if it takes a day to simulate, you can't have instant feedback, but you have to try. There's other projects that kind of do the same. It's like they're more educative tools where it's really nice to experiment and play with, but yeah, they're like toys basically. But like this feedback, that's the good thing. That's what I want to steal. So I want to have this like a real spice simulator, but then steal the feedback part if possible. So where you have this back annotation and it's just live updates when you drag things. I think that should be like, for not huge circuits, it should be possible. And for like long simulations, you can't really do much, but you have to have good visualization still. I think are still important. And then the last key idea, in a traditional simulation UI, like for Cadence or LT-Spice or whatever, there's this UI, and then you can do simple things, and then there's like this cliff where if you want to do like a complex thing, you suddenly have to break out the scripting and like get into this nasty scale thing or tickle or what have you. I think notebooks are a really promising idea to sort of unify this, where it's sort of like a seamless transition from clicking on widgets to converting it to code, to adding custom code, to like offline simulations. It's all the same API, same interface. So yeah, in digital design, you have these test benches, and then my idea is in analog, you have sort of specifications. What if you just make this notebook sort of your data sheet, you know? You run the data sheet, you have your runnable data sheet. You just run the data sheet and you get your specifications out, and you can see, oh, these specifications match, these don't match, and it's less manual waveform browsing and more test benches, basically. And I think also this sort of leads to from design reuse to test bench reuse, where if you make a thing that someone else already made, like an op-amp is not like a new thing to make, you can just take a template for an op-amp data sheet basically, and like run that on your op-amp and then compare, oh, you know, you have two data sheets now, and you can see the different specifications. Yeah, I think that's a promising idea. We'll see how it turns out. So here's a proof of concept where I kind of tried to do this with a notebook and my editor. Yeah, so here you can see I embedded my prototype inside a Pluto notebook and then reactively run ngSpice on the scale circuit and plot the result, and you can just like see instantly change it. This won't work for anything, and it's not how I completely want it to work, but it's like a start for how it could look or something. And yeah, here's a sneak peek of the design that my designer guy is working on, so at some point. Yeah, current status is basically I have a proof of concept of this collaborative schematic editor that's web-based, and some proof of concept notebook stuff. And it's very unfinished and rough, and all sort of stuff is missing and broken, but you can play with it and tell me all those things that suck about it or what that you like about it. And yep, that's it basically. Thank you.